Hello class, today we're going to talk about the average value of a function and the MVT for integrals. First we're going to start off with the average value of a function and what it means and how we can apply it to our math skills. So the average value of a function, this is when f is integrable on the interval a to b, and integrable means when a number can be integrated in a function. So onto the definition, then its average mean value on the interval a to b is the average value of f and then this equals to 1 over b minus a times the integral of a to b of f of x dx. So this is the equation that we're going to use to solve problems. Now we're going to do an example. An example is find the average value of f of x when it's equal to 4 minus x squared on the interval from 0 to 3. And does f actually take on this value? So we're going to use our calculator to find out if it actually does. I put in the function and then we're going to go in under the window and put it from the x values from 0 to 3. And we're going to put the minimum -10 and then the maximum to 5. So as we can see on this graph. So now going back to the definition of average value, it is if f is integrable. And integrable means when you can find the area under the curve, and for which this graph you can. So with this formula, we're finding the average y value, which we can do. How many y values are represented on this curve? You get an infinite number, and this is what this function is for. So from this curve, we can tell if the number is going to be positive or negative, because we can tell that there's more numbers on the top part of the graph instead of the bottom. Even though it's infinite, it's only on the interval from 0 to 3. So now on to solving the actual equation. So the average value of f is equal to 1 over 3 minus 0, because it's the interval, times the integral of 0 to 3. And this is 4 minus x squared dx. So in order to simplify this equation, we have to take the antiderivative of the equation. So we bring down the 1 over 3 in parentheses, and then the antiderivative of 4 is 4x. And then when finding the antiderivative of a squared function, we put parentheses and then you put the x outside, and then you take the antiderivative of that. Inside the parentheses is 1/3, and then outside is x to the 3rd power. And this is all times the integral from 0 to 3. So now as we move on to the equation, 1/3 times 4 parentheses 3 minus 1/3 3 cubed. This is because we're inserting 3 for the x value right now because it's the top number. So now we do the same thing. We use the same equation, but we plug in 0 for it. And since it's 0, it all cancels out and we can cross this all out. So now we can simplify this even further to 1/3 parentheses 12 minus 9 parentheses. And this can be simplified to 1/3 times 3, which is 1. So this 1 value is a y value that we need to know and remember for later on. So now going back to the original equation, the integral a to b f of x d of x, that is just really the area. And then 1 over b minus a, that's just really the base. So the area times 1 over the base, which is really the area divided by the base. And this gives you the average height since you're getting the area and dividing it by the base. So now we remember the curve, and is 1 a y value? Yes, it is. So now we're going to find where this exactly is, what x value it is, without using a calculator. So to find if f takes on the value, set f of x equal to 1 because it's the y value that you found. And now 4 minus x squared is equal to 1. So then you can simplify this to negative x squared is equal to negative 3. And then you can set this equal to the square root of x squared is equal to the square root of 3. And this is equal to x plus or minus the square root of 3. So now we can say that f takes on the average value at x equals the square root of 3. As long as the function is always continuous, we can tell that the average value is always going to occur. Alright, so now on to the next section of my lesson. The mean value theorem for definite integrals. So this is if f is continuous on the interval from a to b, then at some point when c on the interval from a to b, f of c is equal to 1 over b minus a times the integral a to b f of x d of x. As I said before, the average value will always exist somewhere between x is equal to a and x is equal to b, and it will occur at x equals c. Keep this in mind.